a friend of mine and a colleague of mine, Martin Madsen, had just done a study in humans with this radio tracer and looked at the correlation between psychedelic intensity and occupancy at the serotonin receptor. And they had established a dose of 25 milligrams of psilocybin was a really high dose, and you had a high intensity. But what was also obvious from the study was that as you go lower in occupancy and lower in dose, you also had lower intensity. And from the curve of binding to this receptor, we could actually figure out a measurable way to figure out how much is a microdose. And it seems like if people had below 20% binding to the receptor in the brain, they didn't really have any psychedelic effects. So they had they could feel the drug, but they didn't have any psychedelic effects. And the notion about microdosing at the time was that it was a sub-perceptual dose, maybe about 1/10 of a big dose. And as it turned out from Martin's study, 1/10 of a high dose was about right for where they could not feel the drug anymore. And it was about 20% occupancy of the serotonin receptor. So when he had done this study and I knew how this whole system was working and I was a colleague with Martin, I thought, okay, maybe we should actually do it in rats and see if there's something to it. Because in rats, we can do a study. We know they have not tried psychedelic mushrooms before, so they're not biased in any way. We can also blind the participants. We are sure that the rats that doesn't receive psilocybin are not sad about not receiving psilocybin or not don't have a bias towards microdosing producing something good for them. So that's why we chose to actually establish this regimen in rats.
So when you say occupancy, 20% occupancy, does that mean that, okay, so theoretically 100% occupancy would mean that 100% of the 5-HT2A receptors in the brain have psilocin binding to them? Or does it mean that a particular receptor site has multiple binding opportunities? Maybe you can explain that a little bit more as to what this occupancy is and how you determine percentage.
Yes. So the radioactive tracer and a drug that we have that we inject in the body and we can see in the brain when we come into a scanner will bind a small part of the receptors. But we can estimate how many receptors there are from this small part of binding. And then when we give psilocybin, these two drugs will compete for the same binding site. So that will be like a key into the lock of the receptor. There can only be one key at a time in the lock. And psilocybin will then kick off the other one, the radioactive drug. So if you have 100% occupancy, it does translate into all of your 5 serotonin receptors being bound by psilocybin. That is probably never going to be the case. We tried to estimate how much was the maximum occupancy we could get at, and in rodents and rats, we get about 60 to 70% of the receptors when we give them a really high dose. So with this, we can then calculate that if about 20% of the receptors are occupied by the drug, you don't really have any psychedelic effects. And we call that a low dose and not a microdose.
Okay, so something I found interesting. So you came to the conclusion, or you determined that in order to get this 20% occupancy in rats, they needed about 0.05 milligrams per kilogram of psilocybin, which if I translate that to humans based on those same numbers, then for a 70 kilogram person, total that would be about 3.5 milligrams of psilocybin. Average your standard.
Go ahead. That's actually almost on point what Martin reported in their study. They found about 3 milligrams was about 20% occupancy.
Okay, so what was interesting is with mushrooms. Okay, so I'm kind of combining two questions here, so we'll see how this goes. With say, the standard dosage of psilocybin in like a dried, middle of the road psilocybe cubensis, of course, like potency can vary to, strain and then species of psilocybe, but just middle of the road cubensis, that 3.5 milligrams would amount to about 0.5 grams of mushrooms, which certainly, again, a lot of variation in mushrooms, variation in people, and in sort of subjective tolerance, but also, maybe genetic variations in how they metabolize this compound. But what was interesting to me is the idea of hearing that 0.5 grams of mushrooms would equate to what, at least when I first read it, I just assumed when you said low dose, you meant microdose. This is perhaps my error. Like 0.5 grams is pretty high. Like I tried being like, maybe I'll try 0.5 grams as a microdose. And it was like that stereotypical, like, this is not a microdose moment. So I guess the question is twofold. Like, one, why this maybe discrepancy, like why it is.
Yes.
And then the other one is like, what's the difference then between the rats and the humans, such that it would theoretically need more for them to get this 20% occupancy if the rats are generally used as a sort of good model for seeing how a human brain might theoretically respond to certain drugs.
Yeah. So there's several parts to that question, and I think the first one is, so you sent me your calculations beforehand, so I saw that you estimated 0.65% psilocybin in the cubensis. We actually tried and measured it in some cubensis and got 3.5%. So obviously there's a huge difference in how strong are mushrooms. So it really depends on where you grow them, how you grow them, and whatever. So I personally wouldn't translate it into mushrooms in that way. That would be really difficult. It's probably better to try the mushrooms you have and dial it down. Also in science, we rarely use mushroom extracts because it's so variable. So always in science they use pure psilocybin, and 25 milligrams of psilocybin is one of the most used doses of high dose psilocybin in clinical studies. And if you then look at it, 3 milligrams of psilocybin is about 10% of that. So I would be careful to translate it into mushrooms, but I think the 3 milligrams of psilocybin is pretty close to a micro, maybe a mini dose.